Hello, I'm Riccardo DiVirgilio, and I will be speaking about Wolfram Web Engine for Python. Hello, everybody. I'm Riccardo, and we are going to talk about Wolfram Web Engine for Python. So, what is Wolfram Web Engine for Python? This is a new open source library. People are still getting in? Okay. So Wolfram Web Engine for Python is an open source library that is available already on GitHub and allows you to develop and publish web applications locally using Wolfram language. So this library can be used with any kind of Wolfram kernel, including the one that comes with Mathematica 12, 12.1, but also with the new free Wolfram engine for developers that allows you to create and develop applications for free. And you can use this system in order to create application entirely using Wolfram language, or you can incrementally update existing application that you already have in Python. And so during this talk, we will see how to do that, how to create from scratch a new application, and how to increment a new Python, an existing Python application. The one will be a Django application. And we also show how to take existing Wolfram language code that works on the Wolfram cloud and just take this code and see how it works on your local machine. And at the end of the talk, I will explain differences with and advantages with using the public cloud, when should you use that, and when you should use this system. OK, so let's get started. Here there are some links to go on GitHub. Like on GitHub, there is the documentation for Wolfram Web Engine and all the options. And so if you want, you can go ahead and take a look at the documentation. What you need to do is just to have Python 3 installed on your machine. And then just, because this is a Python 3 only library, and just go ahead and pip install Wolfram Web Engine. That will take care of installing all the dependencies and all the code you need to get started. And then there is also like a link here for Wolfram client for Python, which is a library that I was presenting, I guess, 1 year ago here with another colleague, Dorian. That is basically a library that allows you to evaluate Wolfram language code using an external evaluator, a local evaluator, all within Python. So let's take a look on how it works. On the high-level perspective, this is just, we are using a Python framework that is called AOHTTP, which is a very modern framework implemented in Python 3, doing heavy use of coroutines and async functionalities. And within this framework, you can specify web pages, but also any kind of other contents, PDF, whatever dynamic content you want to serve. And you can use standard Wolfram language functions, such as API function, form page, URL dispatcher. Those are all documented functions that you find in our internal documentation. And all those functions, they just work seamlessly with this framework. So I cannot stress enough that this software is open source. And the nice thing is that it's built on very solid foundation, I think, because AOHTTP is a production server that has been around for years, and it's very fast and efficient and well used. And also the client library is getting very mature, because we presented it 2 years ago, I think. And during the last year, we have done a lot of improvements. So external evaluate between 12 and 12.1 just got a performance boost that is something around 300, 400% for normal use cases. And this is done because we have made a lot of improvement in data transfer, in serializing numeric arrays and things like that. So when you're using this library, all the performance improvements that we have done in Wolfram client library are here for free. So once you basically just need to start a new terminal session and do pip install Wolfram Web Engine. This is already done on my machine. And what you need to do here is just to start the demo by running this command. The server will start. It says that it's available on this location. So we can just go ahead and open the browser, and we should see the demo application running on my machine. So this is just form function. It's very simple application. Let's see if this is actually working. So we just take an image from my downloads, whatever. And then the second is to just apply a filter. So what this form function is doing is just to apply a filter to the image and return the image. So we just run it, and we got the filter applied to the machine, to the image. So this worked, fantastic. We can try to do something real now. We can, within this framework, we let you build an application using two different systems. So one is to use a single file with the URL dispatcher, and another one is to use multiple files in a directory layout. So let's start with the first one. The first one is something that is, so URL dispatcher is a function that is documented in Wolfram language. That is just a URL router. This concept should be familiar for people that are doing modern web development. So a lot of Python frameworks like Django, Twisted, Tornado, they all work like that. So they just have a specification of URL path and a function that is executed when the URL path is visited by the user browser. And so in this case, on the left-hand side, we have some URL paths, and on the right-hand side, an expression that needs to be executed when the user goes on that path. So we can basically evaluate this code and create this file on my machine. We can take a look at what's inside this guy with normal text editor. So this is just Wolfram language input form code that I have on this file. And now I use the same code that I was using before, but instead of running the demo, I just put in the path to that file. Now I open the browser again, and I see hello world, which is what was expected because we were specifying that on the home page, I want to see hello world. Now, again, if I go on different paths of this application, here I have a form function, and here I have an API function. So nice thing about this system is that this is just source code, and if I go ahead here and just change something inside it, I don't need to restart anything. I can just go on this page, refresh the browser, and changes are live. So here I can have something dynamic like a random real, and refresh the page, and every time I get a different number. Or I can have, I don't know, like a different image every time by doing random image in PNG format. And now every time I refresh the browser, I get a different image, PNG. I think this was it for a single file layout. The next system is multiple file in a directory layout. This should be more familiar for people who are coming from more traditional web frameworks like PHP, Java servlet pages, things like that, where you basically have a directory structure in your machine that maps directly with the URL path of the user. And so here what I'm doing is just to create a test application on my machine, and this is just code that is producing a bunch of files there. I can go ahead and open it on my machine, and you should see that I have this folder structure. So if let's inspect this folder structure on a text editor again. And here, as you can see, there is just a lot of files and folders. And let's see what is happening when I try to run this application. So I just take the folder path this time. And as before, instead of saying dispatcher here, I put the new path, so test app. Run it again. Now this is saying that it's running on the same port, but on a different location. Fine. Now I refresh the application, and I see what is happening in the home page. So there is a frameworks that are thinking in this way. There is this convention where the folder got an index file. And so in this case, this index.ws was returning a JSON response with the Unix time, whatever it is the Unix time in my machine at this moment. So if I update it, you should see that the number is increasing. And so, yeah, there are other resources here. One is response. Again, here, if I go there and just change something, I'll lower this name. Changes are live again. If you have some static content is directly served. So you can just go here on static JSON. This is skipping the kernel, so it's served directly by the server. And again, here there is a folder, and if you just go there under /API, the index file is executed, and the API function code that is inside here is executed again. And I can have, form function and whatever. So this was how to structure an application using multiple folders on your machine. And the next one is how to integrate an existing application. So I was saying that this framework got bindings for some popular libraries. At the beginning, at this moment, we only have two of them, Django and HTTP. But we would like to add support for more of them. So if you guys have, I don't know, like a framework that you're using and you're interested in it, you can just go ahead and go on GitHub and open an issue. And maybe also, if you want to start contributing, because this framework is really simple and easy to understand. So it's very easy to add support for other libraries. So as soon as we got requests and other people contributing, we are willing to add more and more support for existing frameworks. What we can do here is to show how a Django application can be augmented. What I will do is to just open the source code in the library. There are examples in there that are also available on GitHub and in the README. So under examples, there is a Django application here. And I don't know if you guys are familiar with Django, but this is what a Django application looks like. So again, you define a URL pattern that takes some request path, and then you map a function to it. A function is just something very simple that takes the request information, like this one, and needs to return an HTTP response. So if I just run this application in the way you're supposed to run a Django application, so you just do stop the other one, Python 3. You have a manage file, and then you do run server. This is now just starting a Django web server that runs on port 8000. So I just go there and see if this is working. Yes, it's returning the HTTP response that was specified here. But now what I have here, I have also two other views that I implemented that are using a kernel. So again, if I just go under /API, I have an API function response. And under /form, form function response. Now this is done. This is done by importing that class, Wolfram language session, which is something that is documented under Wolfram client. And this is just an high-level interface to evaluate Wolfram language code. So you import this evaluator that allows you to execute Wolfram language code. And there is a constructor for Wolfram language code. This is also documented under the Wolfram client. And you can, in Python, create symbolic Wolfram language code with this syntax. And then I'm just adding a decorator to this function that says that this function is handled by the kernel, by this session. And so now, what this is doing is that it's taking the Django request and asking the kernel to return an HTTP response. The nice thing here is that this is just Python code. So here you can go ahead and say something like if request user is authenticated, something like that, do something. Otherwise, do something else. So here you can just use your existing authentication middleware, whatever it was, and behind that return some kind of, and ask the kernel to return an HTTP response. So you can keep your existing business logic and start using Wolfram language with a few lines of code. Another interesting thing is that Wolfram client exposes several kind of evaluators. This is one of them that allows you to start a kernel and always execute code on the same kernel, but there is also a kernel pool that is implemented, so you can just, instead of importing that guy, import the kernel pool, and now you have a kernel pool of 4 kernels that are handling requests, and basically every time a request comes in, the first kernel that is available is handling a request for you. Or you can use the cloud evaluator, get the same API, you can just import that and use the cloud to do the evaluation. Now, of course, there's going to be network latency and so on, but you don't need to install anything locally, and it will just work. You just need to provide your cloud authentication information. OK, so this was how to basically increment and augment an existing Python application. And now let's talk about the differences with the Wolfram Cloud, advantages and disadvantages. So what are the differences here? Obviously, like the Wolfram Cloud is a big product, meaning that is able to manage, let's say, whatever traffic you need to manage, which means that you don't need to worry about the size of your application. You can just, as any cloud services, you can just deploy your single function, single API, and you don't need to worry about managing the hardware, managing the deployment, anything like that. This is not the case for this. And so this can be a disadvantage. It can also be an opportunity because when you are installing, you need to install a Wolfram kernel on your machine, so that you need to do it by yourself. But then once you do that, you can basically run any kind of binary on your machine, which is not something that we allow on the public cloud, because for security reasons, we cannot allow you to run any kind of process or binary on a machine that is shared with other user. But to be fair, this is not a limitation of the enterprise private cloud, where you can disable all these mechanisms and you can just shut off the security, and you can start running whatever you need to run on your machine. An advantage is that there is much faster development and bug debugging. You have seen that you don't need to run and deploy code on the cloud, get back with the response and so on. You can just execute code directly on your machine, and if you print or echo something, the output is going to be on your terminal. So like if in the middle of the code you find some kind of error, you just print it and you get the output directly on the terminal, and you can work with that. Another thing that, yes, and this is not something that and as also, as you can see, like as soon as you change something on the source code, changes are reflected in the browser. And this is not something that you can really do, for example, in Python, because every time you change something in Python, it needs to restart the whole process. It needs to restart the whole web server. Now, it's not a big deal if it is a small application. It takes a fraction of a second to restart. But if it is a big application, it can take also seconds. This just will never happen here, because in the end, you just change definition inside a running kernel, and then you can just update, and changes are done quickly and fast. This is not something that you should probably disable on production because you don't want this auto-reloading mechanism on production, but for development it's really effective. Another thing is that, and I think it's a very important point, is that this is something that is very easy to reason with. Meaning that this is not a giant product and not a giant application. It's built on top of a lightweight web server, AOHTTP, and on top of another library that is not that big, actually, for what it's doing. This library, the core of this library is around 100, 200 lines of code because we managed to leverage some high-level evaluators and classes that we are exposing in Wolfram client. So if you take a look at the source code for this framework, it's going to be like super easy to read and to reason with, which means that it's great because if there is a problem, if there is a bug or something is happening, you can just go ahead and look into the source code. Oh, this is where it's happening, and you can either open an issue for us or contribute it by yourself and just directly fix it because really it's really straightforward. And then I think is also an important point, like having less mental overhead when developing an application. And when this is a good fit. I think this is a good fit for a microservice architecture. So let's say that you have an application that is where the backend is completely separated from the front end. Something like you have the front end that is in JavaScript, so this big, giant JavaScript application that is interacting with one or more backends in a microservice architecture. So you can have like something in Python, something in Java, and so on. Now you can just, add a Wolfram engine and start returning code from a Wolfram web server, and so you don't need to drop your existing backend. You don't need to do anything like that. You can just add something else next to what you already have. So you can keep your existing business logic and so on. And as I was saying before, like the integration with Python allows you to keep any kind of middleware you already got in place. So if you have already an authentication middleware, you can just use it. You don't need to migrate to our way of authenticating user. You can just authenticate the user before, and then if the user are authenticated, just return the API response to them, or otherwise return another response like this is not available if you are not authenticated. And so these allow to keep you like all your existing authentication logic in one place and just start returning and focus on the actual content that you need to produce with Wolfram language. And this comes with easy to integrate with an existing service, because if you have like a Python web server, you have seen that like with a few lines of code you can just run it. I think this was kind of everything. Like what you can also do, and I will show it quickly. I forgot, is that so when you start a test app, there are several options that you can take a look at the documentation for Wolfram Web Engine. One of them, and I think is worth mentioning, is this pool size. And so, as you can see now, this guy is starting an application with a pool of 4 kernel, and they are all starting here. So every time I go now to this application and I refresh the browser, each request is going to a different kernel. Now, you can see that like the first 4 requests are taking a little bit much longer, because there is the kernel initialization time, and then subsequent requests are much faster. We are in the order of, right now, of 7-8 milliseconds of overhead for requests. And that includes, parsing the incoming request, transferring to the kernel, execute some code, transferring back, and return it to the user, which I think is So performance is getting there. We will keep optimizing this, but I think it's already good for some production application.